Hi, Jeff DeAngelis here from Di-Fi Vision Consulting with our fifth installment of our Industry 4.0 Bootcamp series. Today's topic is Empowering Intelligence at the Edge. Empowering intelligence at the edge is a hot topic or the key buzzword heard at conferences, and the term is used by many industrial automation hardware companies to describe their corporate vision and product strategy. In factory automation, empowering intelligence at the edge means increasing the hardware capabilities of the PLC controller and the field-level equipment that manufactures the products and the technology used to move the product through the production or process facility for delivery to customers. The real question is, what are the technologies needed to empower intelligence at the edge? After spending many years working in the semiconductor industry and tracking the evolution of industrial automation, it is clear you need to consider two perspectives when developing a portfolio of technologies to answer this question. From an OT perspective, the portfolio of technologies focuses on delivering intelligent sensors, intelligent and self-aware motion control, software configurable I/O, and connectivity. However, from the IT perspective, it's important to recognize the movement towards the digital factory. As a result, our technologies need to be nimble and develop new ways to accommodate interfacing with enhanced artificial intelligence productivity tools while supporting digital twin models of your manufacturing facility and then sending relevant health and status as well as device performance parameters into the cloud. Let's explore the contribution of technology to help us understand their importance to empowering intelligence at the edge. Intelligent sensors are the genesis that give birth to delivering the new capability of flexible manufacturing to the industrial automation industry. While this is a bold statement, I would argue that it is the most critical technology development in manufacturing that has unlocked the real potential of Industry 4.0. A traditional sensor only provides information in one direction to the PLC, but now with intelligent sensors, it unlocks the ability to hold a two-way communication directly between the sensor and PLCs or distributed control systems that typically sit on the factory floor. This results in faster decision-making at the field level and allows the sensor parameters to be adjusted on the fly. In turn, this opens the door to support the manufacturing of many different products on the same assembly line. To fully appreciate the impact of this capability, imagine you're a Toyota, for example. Having this ability to manufacturing multiple cars across all your factories would provide tremendous savings for the company versus having to establish dedicated manufacturing plants for one car model per location. This magical capability to reconfigure sensors on the fly also provides an opportunity to create unique personalized production batches, reduces commission times, and drives operating costs and reduces downtime by providing the ability to diagnose production line issues by tracking the health and status of the operation. Now let's look at intelligent and self-aware motion control. Intelligent and self-aware motion control also provides similar benefits as the intelligent sensors, but can work in conjunction with an intelligent sensor to form a closed feedback loop to self-regulate the movement of products across the factory floor or regulate the flow of material in a processing facility. To understand these benefits, we need to look at the important role that actuators play in industrial automation. Actuators are used to influence and control the movement of products across the factory floor. Intelligent actuators will provide an auto-configuration capability to automatically adjust its performance to the demands of its operational environment. This is the first step in making the actuator become more self-aware of its environment and allows the system to optimize its performance for maximum throughput or maximizes the operational lifetime of the actuator. In both cases, the results yield lower operational costs and higher efficiency. The third technology area that helps empower intelligence at the edge are software configurable IOs. Software configurable IOs address the need to support new product configurations or expansion needs. These software configurable IOs provide more flexibility and simplify the expansion needs to install new factory equipment while simplifying wire marshaling by providing a universal IO port that any type of analog or digital sensor or actuator can be plugged into. All the commissioning happens via software and as a result reduces the downtime needed to commission the new equipment. Now let's move on to artificial intelligence and the digital twin. Artificial intelligence or AI and the digital twin require consideration at the semiconductor level to simplify the task of AI-enabled productivity solutions and ensuring the correct characteristics of the physical hardware are communicated to its digital twin. The important thing to remember is while this combination of technology is very powerful in predicting equipment failures and ensuring a factory meets its intended manufacturing performance through simulation by using the digital twin, the real value is leveraging this tremendous capability to shape the factory or processing facility's performance based on a desire to optimize factory throughput, support unique customer orders, and operate to improve energy savings and reduce its carbon footprint. Finally, let's look at cloud computing technology. Cloud computing is the end game where the Industry 4.0 facility operational data will reside. At a high level, this will mean many terabytes of information for a small to medium-sized factory alone will need to be published into the cloud. The challenge is supporting the right connectivity technologies to reduce the time it takes to publish the data between the cloud and the equipment on the factory floor, but the need to create more efficient ways to packetize this information and process it prior to sending it into the cloud is where the real hidden value lies. By implementing a smarter approach to the way information is shared to the cloud, it will significantly reduce the burden and the amount of information that needs to be published. Taking advantage of these new technologies will provide better diagnostics to monitor the health and status of the equipment on the factory floor and enable the collective manufacturing fabric of intelligent sensors and actuators to generate higher quality information to make better real-time decisions. If you found today's installment on the benefits of Industry 4.0 interesting, then please remember to like and subscribe to my channel. Stay tuned for next week's installment, and thanks for listening. See you soon.